This chapter will be focusing on binomial theorem. Binomial itself is talking about two terms, for example, a plus b, and this theorem aims to talk about how we can expand a plus b brackets to the power n, in which n is a positive integer. The easiest one for you, of course, it will be the identity you learn in junior form, in which you have a squared plus 2ab plus b squared. So we'll be going to examine how we can expand the expression to the power n. Next, so in this expansion, we have several notations to introduce. One of it will be about the summation sign that we have. You had a bit taste in when we talk about mathematical induction MI. For example, let's see whether you remember. If we are summing up r from 1 to 100 for r squared, what does that mean? Yes, it will be you substitute r from 1, 2, 3, 4 until is 100. And the formula you're talking about is r squared. So that's why we are summing up 1 square, 2 square, 3 square, 4 square, up to 100 square. We will be seeing how this notation will be used in binomial theorem as well. Next, we come to a new notation which is called factorial. Its definition is quite easy. For n, which is a positive integer, n factorial means you are multiplying from 1, 2, 3 up to the value of n. For example, if you are talking about 5 factorial, it means 1, 2, 3, 4, 5. And then 1 factorial, only one number, 1. And then by definition, 0 factorial is equal to 1. And then you may try example 1a by yourselves. For part B, of course, if you need to write the steps, you have 5, 4, 3, 2, and then 1 on top for 5 factorial. And 4 factorial will be 4, 3, 2, 1. And then next, you will see that when we are talking about division in factorial, most of the term will be cancelled by looking at the smaller number. So that's why 4, 3, 2, 1, they are cancelled, and that's why you have a 5. By this situation, can you imagine that, for example, like 9 factorial over 8 factorial? What is it? If you can't do it, just simply expand it, and you will see that 1, 2, 3, 4, 5, 8 up and down, they cancel each other, and so that's why there's a 9. How about if we have 8 factorial over 6 factorial? So you have 1, 2, 3, 4, 5, 6 on top, 1, 2, 3, 4, 5, 6 at the bottom. So that's why the only numbers left will be 8 and 7, which is 56. Last one, 2 factorial over 5 factorial. This time is 1, 2 on top, 1, 2, 3, 4, 5 at the bottom. So that's why we still have 3, 4, 5 at the bottom, which gives you 60. 1 over 60 as the answer. Next, we have another notation very important in binomial theorem, which is called NCR, and then which is given by the definition, a very big formula in the box provide, which is called n factorial over n minus r factorial and r factorial. C itself, it means combination. That we'll go back to talk about it in math in Form 5 afterward. But anyway, let's see how it will be used in binomial theorem in M2 first. By definition, 5C2 will be given by 5 factorial over 5 minus 2 factorial and 2 factorial, which means it's 5 factorial, 3 factorial, and then 2 factorial. But a little trick you have just tried, and then next 5 factorial over 3 factorial will be 5 and 4 left on top, while 2 factorial in the denominator will be 1 and 2. So that's why at last it will be not 20, it should be 10 over there. And then so 1D, you may try it by yourselves. Besides doing calculation directly from by the definition and also by your calculation by yourselves, NCR can be done by calculator. You can check for should be shift times or shift division. Can't remember quite clearly, and you may try it by yourselves. And then next example will be a very tough question because you have numbers, then you can do the calculation. But you have some unknowns or letters over there, so it will be quite hard to do so. And so let's see how we can prove the identity in the question or in the properties as follow. And then first of all, for number 1, because we need to prove it, so that's why we need to use definition. You don't have another way. And as a result, it should be called n factorial, n minus r factorial, and r factorial. Of course, we are not going to expand it to be n minus 1, n minus 2 up to 1. So terrible. So I just pause it and leave it for a short while of the left hand side over there. And then next, we take a look on right hand side. Right hand side will be n factorial, n minus r factorial, and n minus r factorial. It looks terrible, right? But if you read the expression very clearly by yourselves, and you will see that it's just r factorial only. And then now can you see that it's totally your left hand side? Yes, that is. Now the hardest job on this page will be number 2, because the identity itself is very terrible. But before we start, and let's have a very quick concept whether you can manage or not. Do you agree that 4 factorial is 3 factorial times 4? Yes, if it's true, and hopefully you can manage it. And then how about n factorial? Is n minus 1 factorial times n. Do you agree with it? Yes. But if you really find it quite hard in these two quick concepts, you may try to expand the factorial and see the left hand side and right hand side by yourselves. Then how about n plus 1 factorial? Is it n factorial times n plus 1? Yes, definitely. So at last, how about n plus 1 plus r factorial is n plus r factorial times n plus r plus 1. Can you manage it? It's a bit hard. But by the way, let's see how we are going to prove the number 2. Number 2, the same thing will be same happens like on top is n plus 1 factorial, and then n plus 1 plus r factorial, and then very hard, r factorial. But once again, I will just leave it here, and because it's too terrible to expand it. While on the right hand side, you have n factorial, n minus r factorial. Oh, sorry, I find I make a mistake on top, which is n plus 1 minus r. Okay, let's go back to your right hand side at r factorial plus n factorial. Wow, it's getting terrible now. N minus r plus 1 factorial, and also r minus 1 factorial. And because you have two fractions compared to the left hand side, that means I'm going to merge the fractions here. So in order to merge the fraction, so the denominators should be matched to each other. That's why, take a look here. The right expression requires you to have n minus r plus 1 because it's a larger fraction. So that's why on the, in the first fraction, you need to multiply n minus r plus 1 first. So that's why the denominator becomes n minus r plus 1 factorial. So try hard to understand it. It's not easy to understand at once. While comparing r factorial r minus 1 factorial, r factorial is larger. It doesn't matter. But if you want to turn r factorial also in the second fraction, then it should be, you need to multiply r on top. So that's why n factorial on top, n minus r plus 1 factorial first, and finally multiply to r factorial. So in this situation, so now you can combine the fractions together, and if you read the expression carefully enough, you will see that the denominators, they are identical already. So that's why your aim now comes to, you want the things on top will be n plus 1 factorial. Let's verify it together. And next you have n factorial n minus r plus 1, and you have n factorial r not factorial. Okay, at last n factorial is a common factor, and you have n minus r plus 1 plus r. Denominator no change. So as a result, you will see that minus r and plus r, they cancel each other. So that's why you obtain the formula which is equal to the left hand side. So it helps us to prove the two identities, prove two properties in NCR. But it will be a very hard examples which is examining you whether you can use the definition of NCR to prove something. Next we come to the revision on the summation notation, which is called the sigma symbol, which is summing up the terms. On the first page, I try to use summation of r squared, and indeed you can use any letters, somehow any letters as you like. For example, using I here. And then next, let's see whether you can you do remember how we can expand the summation sign in this question. For example, A I will demonstrate for you, and part B, C I leave them for you as an exercise. Now you're summing up from 1 to 4, so that's why it's 2 times 1 plus 2, 2 times 2, that means 4 plus 2, 2 times 3, 6, and 2 times 4, 8. So this is the meaning of the summation sign in part A. 2 times 1, 2 times 2, 2 times 3, 2 times 4, and you've got the results. And at last, you use your calculator to sum the things up. So what's that? It's 28 afterward. So let's try part B yourself. Next, example 4, I want to see whether you can use summation sign to combine them. The main point to do so would be you have to find a formula of all these numbers. For example, you find that these are, what's that? Even numbers, of course. But even numbers, normally we can use 2k to represent it. So that's why it's summation of 2k first for your answer. And secondly, then you see the starting point is 2 times 1 for the first number, 2 times 2, 2 times 3 for the third number. So k is starting from 1. Now you check for your calculator, 2012 is 2 times, yes, it's 506. So that's why it's to 506. For example 4a. Summation sign can be signed from 1 or signed from any number, like what we have in part B. Part B, I guess you find the formula quite easily, so it should be something about r squared. So here you see that I intentionally use different notation to in our summation sign. So this time I use r, previously I used k, both are okay. So now you have summation of r squared, but this time r starting from 4. So we say r starting from 4, while the end number will be 12. So r is ending at 12. So this is the way how we present part B. Some of you, if you insist to use r starting from 1, so that's why in order to get a 4 at first, it should be r plus 3, bracket square. So this is another way to present summation of 4 square, 5 square until 12 square. And then, but in this case, if you use r starting from 1, and 12 would be 9 plus 3. So that's why the summation is, it ends at 9. See, I leave it for you. Is it alright? I don't think so. Because you find that the pattern is not very clear, because you can't see the number 1/2. There's a little trick behind it, because it's 2/4. Is it better for you? 1/3, 2/4, 3/5, and 6/5 puzzle. Because you're supposed to have like 4/6 here, right? So that's why it's not the real looking. We have to check it out. Is it 12/10? Do you agree with it? Yes, certainly. Because the pattern of denominator will be 3 minus 2 is 1, 4 minus 2 is 2, 5 minus 2 is 3, 6 minus 2 is 4, etc. So that's why this time the summation sign would be in the form of n minus 2, n which is starting from 3 because the first number and ending at 12. So it is one of the answer. Next job would be if I start from 1, so it should be n plus 2, on top is n. So can you try to work out the answer the ending number by yourselves? Yes, in this case it will be ending at 10. So this is another quick exercise about summation sign.